Hi everyone, this is Kona, and I'm going to go through the Minitab T-Test example questions. So we're going to be using this Minitab file that should be right there with this handout. And let's go through a little bit of the data dictionary. So the data was collected by a random survey of Math 113 students. Gender, we had two options, levels, choices, male, female. We had hours worked per week as another variable, and that was just the number. So this is a numeric variable of the hours the person works per week. Pretest was the score out of 100 that the person got on the Math 113 pretest. This is the practice test taken before studying for the test. And then we've got the test, which was the score out of 100 that the person got on the Math 113 test. And that's the test given after the practice test and studying for the test. So those are our variables right there. We only have one categorical variable, the male and the female. Otherwise, we've got three numeric variables right there. So let's look at our first claim. Men work less hours a week than women. So step one, which type of test? Well, for it to be a one sample t-test, you would need to be comparing a number to a claim number, a claim variable, claim number. And we're not comparing something to, or an average to, a claim variable. We're comparing the number of hours a week that men worked to women. So that doesn't work. One sample t-test doesn't work. Paired samples t-test. Well, to be a paired samples, you would have to have paired variables. Well, the men and the women aren't a paired variable. It's not like this is a husband-wife couple. This isn't like they're being paired on any variable. These are just random men in the classroom and random women. So there's no pairing going on there. So process of elimination, it is a two-sample t-test, but also it's the two-sample t-test because you've got one variable that's a categorical variable with two options, and it's being used to compare the numeric variable, which is the hours worked per week. So check necessary assumptions. Well, this is independent, and I think we did say it was a random sample. So otherwise, we would just assume that, yep, we're good. So original claim, is it the null or alternative? It is the alternative, and that's because it's the less than, less hours, which that's an alternative because there's no equality, and uses the left tail because a less than is a left tail or side. All right, so now we're going to use Minitab to analyze the data. So let's go over to Minitab, and there's our gender, our hours worked per week. And what we're going to do is go up to basic stats, two sample T. Both samples are in one column. As soon as you click on the samples box, these will come up. Samples is your numeric variable. That's the actual number, so that's the variable that has the numbers in it. So in this case, it's hours worked per week. Your sample IDs are how you're organizing or comparing things, which in this case would be gender. You then look at your options, so 95, 0 difference, and in this case it's a less than, so you need the less than. Click OK and click OK, and here you go. All right, so you might think, okay, yay, we're good to go. The problem is that here we're comparing, because female, male, so we're comparing the mean of the female minus the mean of the male. Well, that's not the same as what we hypothesized or what we claimed. Our claim was that men make less than women. So here we're doing the women minus the men. That's kind of the flip-flop of what we want. Minitab does this. It doesn't let you pick the order. Right here it's going to go alphabetically, so that's why I did female minus male. So in order to get what we want, which is male minus female, we're going to have to actually recode this data. So we're going to come up to Data, Code to Numeric, and pick Gender, Method, to Individual Variables. So here, see how they've got female first and male second? We're going to actually flip this around, make female second, men first. We're going to add it to the current worksheet. We don't need that. Click OK. All right, so now we have our coded gender. So what we can do next is go back to Stat, Basic, our two sample T. Now, instead of the sample ID being gender, it's going to be our coded gender. The options stay the same, so just click OK, and here you go. So now our 1, remember our 1 was our males, are being subtracted. The mean of the males is being subtracted from the means of the females. So these are different variables. If you look, our p-value is 0.604, and here our p-value is 0.396. So granted, they're both both greater than 0.05, but they are different. You're also, the t-value here is a negative t-value, here's a positive t-value. So doing this, you would get the wrong answer if you had left it this way, because you're going to have the wrong p-value, wrong t-value. All right, so now that you've got this, when you actually go to submit this for, say, a project or something like that, I'm going to ask you to include this data right here. The best way to do that is going to be to use the snipping tool. And the snipping tool, if you come and click right here, and that should be like your start button, and click snip, and it should come up with snipping tool. Unless you have a Mac, you should just have this snipping tool on your computer. So go ahead and click snipping tool, and what it's going to allow you to do is select what you'd like to snip or copy, and there you go. Then you can just press copy, and then if you were in a Word document, so I'll just open a Word document really quick, and let's say you were typing your project in your Word document, and then you can now paste, and there you go. And now it pasted it nice, pretty, and looks really good. If you tried to just copy and paste that, it would look really ugly. I'm not going to save this, or this. But if you just tried to copy this and copy and paste, it doesn't always look the best. That's where the snipping tool really is pretty nice. But okay, so here's our data, and we're going to go back to this one. So here's our data. Our number of men is 9, number of women is 6, which that's fine. They don't have to be the same because we're not doing a paired samples test. Mean number of hours worked is 25.6. Mean number of hours worked for women is 23.2. That's from right here. Our t-value is 0.27. Our p-value is 0.604. So we're good to go there. So make a decision. There is or is not. Well, this is an is not because that p-value is greater than 0.05. So that's where it's since the p-value is greater than 0.05, it is and is not enough evidence to reject support. It's a support because this was our alternative, and anytime you have the alternative, you support. If it was to be the null, it would be reject. But we are using the alternative, so that means it support the claim that, and then you just restate whatever your original claim was, which men work less hours a week than women. But okay, so we're rejecting our claim, right? Well, what does that actually mean? So what does this mean in real world terms? It means we can't actually say that men work less hours a week than women for the students in the sample. We can't say that it proves anything because we don't ever prove anything in statistics. What we can say though is that for this specific sample, men don't work less hours a week than women. But looking at the 25.6 versus the 23.2, it looks like men maybe work a little bit more hours. So what you would do next is say, you know, let's check and see if either there's a difference or if they're greater than. So we're going to come back here and we're going to do the follow-up. So the follow-up is stat basic to sample t. This time we leave all of this the same, but in options we're going to say the difference, instead of being less, we're going to say the difference is greater than. So we're saying that men make more than women. Click OK. Click OK. But look at this p-value. That p-value, the 0.396, that's still an is not. So if we went back here, so the p-value of an is not, it would still be there is not enough evidence to support the claim that men work more hours. So that still doesn't work. So really there's no difference. So just to double check that, what you would do is stat basic to sample, and this time you would just do the no difference. Okay, okay. And if you do the no difference, you get this p-value right there. So you can see that there is no difference, even though it looks like there's a difference, and this is why we actually do the statistics. This is why we actually do the data analysis, because if we just eyeball it, we would say, well, yeah, it looks like there's a difference between the number of hours a week men work compared to women, because it does look like men do work more hours than women. But when we actually do the data analysis, we see that, because this one is the no difference right here, there really is no difference at all statistically in the number of hours they work per week on average. So back here, So we can't say that men work less hours a week than women. Follow-up analysis indicates that there is no difference between the number of hours men and women work per week, and then you would actually include that. Hold on just a second. Hello? Okay, I am back again. So what does this mean in real world terms? We can't say that men work less hours, and the follow-up analysis actually indicates that there's no difference. And then when you do that, make sure to include the t-value and p-value for the follow-up analysis, just so you can see this is where it's coming from. So let's move on to claim number 2. There is a difference between the average pretest score and test score. So first of all, which type of test? Well, it's not a one sample t because we're not comparing something to a claim value. A 2 sample t-test compared to the paired sample. Well, for the 2 sample, you normally need a categorical variable that you're comparing things, the numbers then between. And here there's no difference between the average pretest and test. Well, we're comparing 2 different numeric scores, 2 different numbers. And so there's no categorical to kind of separate them, to compare them. So not the 2 sample t. Also, because we're looking at the average pretest and test, well, those are kind of paired because we've got the pretest score for the same student and the test score for the same student. So it's actually the paired samples t-test. So check necessary assumptions. Well, they are dependent. They are random. Well, we'll assume randomness because of how they were collected. So the original claim is that the null or alternative. Well, we're saying there is a difference. So the difference meaning they're not equal. So that's alternative. And both tails are sides. We then would use Minitab to analyze the data. So we'll go over here to Minitab. And this time we're going to go to stat, basic, paired t. Each sample is in a column. And we're going to do the pretest as sample 1, the test as sample 2. Under our options, 95, 0, and we are saying because we said that they're not equal, so do that and click OK. So here we go. Here's our data. This is what you would snip. You would snip all of that right there, but now I'm going to go ahead and flip back to this. So there is the data right there. So the number of pretest scores is 15, number of test scores is 15. Mean pretest scores is 75. Mean test scores is 81.18. The t-value is negative 2.70. That's this one right here, and our p-value is 0.017. So if you make a decision, there is enough evidence, and there is, because this p-value 0.017 is less than 0.05, enough evidence to reject support. It's support because we are using the claim was the alternative hypothesis. To claim that there is a difference between the average pretest scores and test scores. So what does this mean? It means that the pretest and test scores for the students who were sampled are different. So it doesn't prove anything. It just means that the real world, that the test scores are different. But we need to do the follow-up analysis to indicate then which one. So it looks like the pretest scores are lower than the test scores. So I would do the follow-up analysis to check to see if the pretests really are lower than the test. So you're going to come back up to stat, basic stats, paired, and this time under options, we're going to say the hypothesized difference is less than. Click OK, OK, and you can see that they are doing pretest minus test because this one, see, pretest minus test, so you're good there, no recoding. And look at our p-value. Right there, our p-value is 0.009, right? So if we come back down here, so since our p-value is the 0.009, that means that there is enough evidence to, it's still support because we were saying that the pretest was less than the test. So there is enough evidence to support that the pretest is less than the test value. So our follow-up analysis indicates that the pretest scores were lower than the test scores. So this is why it's very important to do the follow-up analysis if needed. So if this had said that there is not enough evidence to support that the difference, so if there's no difference, then we would just stop and we wouldn't do the follow-up. But because there was a difference, that's why we had to do the follow-up to see what the difference was. So claim 3, women's test scores are different than men's test scores. So in this case, which type of test? Well, we're not comparing it to a claim value. The paired sample t-test, well, it's not this one because even though we've got the test scores here, we've got this categorical. We've got the women and the men, which is that gender, which is that categorical variable, which makes it the 2 sample t. Also, we don't have any paired data because the women and the men aren't paired. That categorical variable there isn't paired. Check necessary assumptions. Well, they are independent because they're not paired and they were coming from a random sample of students. So is the original claim the null or the alternative? Where it is the alternative because we're saying that the women's test scores are different than the men's, so different meaning not equal. And it uses both tails because different is the non-equality thing, so that's the both tails. Then we're going to use Minitab to analyze the data. So this is a 2 sample t-test. So we're going to come back to graph. Also, really quick, this time we are doing women first and then men. So when we look here, this one, the coded gender was men and then women. Gender is women then men. So this time when we go back up to stat, basic stats, 2 sample t, instead of our coded gender, we're actually going to go back to this one right there. And instead of hours worked per week, we're going to change that one, and now it's the test scores. And we were testing just to see if they were different. So here, we're going to say that this is different. Click OK, click OK. And so here's our data right here, and look at that p-value. That p-value is not less than 0.05, but this is what we would snip. So we're going to head snip, come back over here. There's the data right there. So number of women 6, number of men 9. Mean test score for women was 79.3. Mean test score for men was 82.4. The t-value was negative 0.48, and the p-value is 0.643. So make a decision. There is not enough evidence, and that's because this p-value is greater than 0.05. Enough evidence to reject. Nope, it's support. Because remember, it's alternative. Alternative is support. Reject is null. The claim that women's test scores are different than men's test scores. So there is not enough evidence to support the claim that women's test scores are different than men's test scores. So what does this mean in real world terms? From the sample, there's no difference between the women and the men's test scores. We don't need to do follow-up here because we're saying there's no difference. If we said that there was a difference, so if there is enough evidence to support the claim that there are different, then we would do a follow-up to see if one is higher than the other. But there is no difference, so we just stop right here. So let's do our fourth and last claim. The average number of hours worked per week by students is less than the national standard of 40 hours. So which type of test? Well, this time it is the 1 sample t, and that's because we're comparing a numeric variable to an actual claim variable, which is our 40 hours right there. Necessary assumptions, once again, it is random, it is independent, so we can move along. So is it alternative? Yes, because we're saying that the average number of hours worked per week is less than. So it's alternative because it's not equal, and it's the left tail. We'll then use Minitab to analyze the data. So come back over here, and we're going to go to Stat, Basic, 1 sample T, once more samples in each column. And so for this one, remember we're doing hours per week. We're performing a hypothesis test. Our hypothesized mean is 40. And for options, we leave the 95, but in this case we're saying that is less than. Remember, we're saying our mean of the number of hours that our students work is less than the hypothesized mean of the 40 hours, which was the national average. Click OK, click OK, and here we go. So this would be the data that we would snip. And then come back over here, and there's that data right there. So the mean number of hours worked per week was 24.60, and that's by our students, and that's what we were comparing that 24.60 to the 40 hours. The t-value is negative 3.55, and our p-value is 0.002. So make a decision. There is enough evidence to support the claim that the average number of hours worked per week by students is less than the national standard of 40, which makes a lot of sense, right? Because 24.60 is lower than 40, quite a bit lower. But just because it looks lower, remember in that first one, it didn't mean anything. It statistically wasn't lower. Here, it statistically is lower. So what does this mean in real world terms? on average, the students in the sample worked less than 40 hours per week. We don't have to do any follow-up because we were able to support this and say that there is enough evidence to support. If there was not enough evidence to support this, then we would do the follow-up. But we don't have to do the follow-up because we can say the students in the sample did seem to work less than 40 hours per week. But remember, do not use the word prove. We're not proving anything. We're just showing on average that these students did seem to work less than 40 hours per week. So I hope all of this made sense. Good luck, and let me know if you have questions.